This is a teardown of an Emerson Liebert PT4 series battery backup. And the particular model of this is PT4-500MT120. This is a 500 VA battery backup running at 120 volts. And you will need a long Phillips number 2 screwdriver, except I think mine might be too thick. Actually, I think I'm going to go with the number 1 Phillips. I'll be back. Alright, so I think for instead I'm going to go with number 1. It's the wrong tip size for the screw, but these holes are really small, and as you can see, the shaft size, maybe if I do it this way it'll be a little easier to tell. The shaft size is a bit smaller. When you do use a undersized screwdriver, you want to make sure you put extra force down so you don't strip the head of the screw out. But otherwise, these are technically number 2 Phillips head screws. And they are, oh shoot, what do you call these screws? They're the type of screw that cuts threads into plastic. I should know the term, but I don't. And there's the battery, so you want to know how to get the battery out. There's that. And boy, that is a small little battery. I mean, it's a small battery backup, so yeah. And that's the battery it uses if you are interested. 12 volt, 5 amp hour, and standard F2 terminals. It's the little guy. A little rattle to it. Let's set that on the floor. Hopefully that doesn't have charge. And 4 more screws to get inside the battery backup. And ta-da! There's the bottom side of the battery backup. Just gonna look here. I should probably see if this has a charge. That doesn't seem like it. Are there any big capacitors? Nope. Man, this thing's light. Once you get the battery out, there's just not much to it. Just trying to see how to get this out without touching anything too sensitive. It's nice that these PCBs have removable cables that interconnect them. One of the data lines. That actually was going to the filter board and then your USB interface. Just gonna tip that back for now. We're gonna look at this filter board first, I think. And I might need some wire cutters, it looks like. Yes, this board doesn't have very big capacitors. The 3000 VI one I tore apart in the previous video, those are pretty scary when they have charge, because those capacitors pack a punch. Well, I think I do need wire cutters, but I think I'm just going to keep taking out screws. Should be using a number 2 for this, actually. Just make things easier. Not sure what this board in the middle is. I think it's just a power distribution board, because this I'm guessing is half on battery backup and half on surge protector. Alright, I'm gonna grab wire cutters. Alrighty. So here's the breakout board for the USB interface, and then your filtering for, I believe it was Ethernet. These look like Ethernet jacks. It's not labeled, but pretty sure it's Ethernet. Oh, wow. Got a bunch of diodes there. I don't know what that is. It's an IC chip, but what's it doing? Camera won't focus, it's so annoying. Got some opto isolators there. Where is this chip getting its power from? The opto isolators are across everything. This chip must get its power from the USB port itself. Fascinating. I don't think I've seen that before in a battery backup. That's really interesting, because if that's the case, that's basically 100% isolating your battery backup from your PC if you have it hooked up over USB. I don't think there'd be a return to ground. Well, nope, I lied. You got this ground wire here that's going to this shared ground plane. You see all this copper or not, the plating or whatever on the board. And it looks like a little reinforcement jumper there. So never mind. I don't get why they did that way. Ouch. Is that readable? Alright, I need to scrub at that with some rubbing alcohol, I think. I'm not going to have a clue what that chip is, but at least I can show it in theory. It's probably something really cool, I don't know. Will it be readable on camera? I don't know. CY7C 63743. Closer seems to be better if it'll focus. Light. Whoosh. Yeah, I don't know. That's the best you're going to get, unfortunately. And then just a bunch of diodes, I pointed out earlier, and these are your opto isolators. I think it's upside down. Anywho, camera's not playing nice. I think these little things here are mauves, the little orange-yellow things. Those are doing the protection against power surges. See this here. Oh, okay. So power distribution board and power filtering, it looks like. Oh no, those are LEDs. It's like little neon bulbs. That's fun, but nope, just LEDs. Not so fun. Let's see if I can get this free so we can take a closer look. I assume the yellow things are capacitors. They got a little coil in the middle. So I assume this is doing some sort of low-level filtering as power goes in. 1 microfarad each, 275 volt rated. And it looks like connect across those pads. And this little toroidal transformer somehow must pass the power through, because I don't see any other traces in between that gap. Alright, now the exciting part. Just cut this board free here. All these wires. Let's go nicely in my little copper bin. If it was an APC, I'd be a little bit more inclined to care about it. But these random brands, they're just so undocumented that they're not even really worth thinking about from a secondhand standpoint. So here's the main PCB. Probably would have been interesting to be able to follow the path of power, but I cut all the wires off, so a lot of solder there on the back to thicken those traces. And there's some over here as well. But obviously this section here is doing the power inversion from the battery to get your 120 volts out when your power goes out. Some beefy chunks of aluminum there. Not very much fin there though, but there's no airflow I suppose internally anyway, so who cares, right? This, I believe, is where the power was coming in. Kind of this corner. Just have to look at this without the camera a little bit. It's hard to look at things through the camera. Huh. A little discoloration on that part of the board by that diode. A couple relays. These controller chips probably aren't going to be of anything of interest. Let's see if the label's not going to peel off nice. Use some warnings on the board. Oops, there's one chip. That one, I'll feel like cleaning the paper off. A little 40 amp fuse there. This corner chip is UTC I don't know. Oh, well, there we go. It's an LM385L. It's probably something common. I'm not going to fight it. I'm just going to add to the video too long. There's an opto isolator right there. And there and there. I'm guessing all this half of the board is all the ACN functionality. Got the brains down here, obviously. Not sure what that does without looking it up. Those are interesting. I don't know what those transistors are doing, but you got 4 of them here in a little cluster. Not very helpful, unfortunately. But yeah, and then with these cheaper battery backups, it's pretty common for them to have the plastic molding in a way where the brass for the outlets is just a press-in deal. I don't remember how this was originally, but basically these slot in somehow like this. It's not quite right. I think it's actually upside down. Slot in. I don't know. Something like that. Let me save the other one. I can screw stuff. Kind of a neat design choice because it makes things easier. Because like on a lot of the older battery backups, they use a lot of steel for the housings, and then they had to use just your regular like wall outlets instead of just making the housing your outlet as well. There we go. So you can see how these are just pressed in basically. So either way, hopefully that was interesting, and thanks for watching.